Hey everyone, today in this video tutorial I will be introducing a sensor that has three parts embedded in the same part. That's the accelerometer, magnetometer and the gyrometer, and it's known as LSM9DS0. Now to gain more knowledge about that, let's roll upon the website that is controleverything.upon and search for this particular sensor, and let's see what we got. As you can see, it's a 3D accelerometer, 3D gyroscope, 3D magnetometer, and as you can see, a long list of features for it. And also you can purchase the sensor from here. Furthermore, I will be interfacing the sensor, that is LSM9DS0, with Raspberry Pi and Java code. And to get the Java code, what I will do is to go to the resource tab, and here let's click on the Java code sample. Now you can download the Java code sample from here as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. Now what we require is to have a look over the connections of the hardware material. Let's have it. In the hardware section part, the requirement is a Raspberry Pi, which you are able to see on my screen, and these are the GPI pins of the Raspberry Pi. Now this here is an I2C Shield. It's available on the website controleverything.com, and you can purchase it from there. The real reason we are using this I2C Shield is to make connections easier with other I2C devices. So we use it and gently place the I2C Shield over the GPI pins of the Raspberry Pi, and we are done. The next thing we require is our sensor, that is LSM9DS0, and here comes a connecting cable. Now make the connection of the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C Shield. Now we require a micro USB cable just for the power connection, and gently insert it over the power jack. The last part is to provide an internet connection for the Raspberry Pi, and there are two ways. The first way is to provide an Ethernet or LAN cable, as you can see, and gently insert it over the Ethernet jack. The next part is to provide the internet connection via a wireless nano USB adapter, which you are able to see on my screen. It comes in handy and it might save you a day also. Now as we are done with all the connections required, now what we require is to look over the code. So let's interface. Now coming to the interfacing part, the first step is to find the Java code, and let's have a look over github.com, and here we have to search for the repository, that is Control Everything Community, and as you can see, here we go, and this is the required sensor LSM9DS0, and this is the Java code. But before moving forward to explore the Java code, let's have a look over the instructions we need to follow. As you can see, in download, we have to download and install Pi4j library on the Raspberry Pi, and the steps are provided on this very link, pi4j.com. Let's open up this link and see what we got for the instruction part. As you can see, we have some of the commands, installation steps to be followed to pursue this library. Please do it carefully. Now as you can see, this is the command to compile the Java code, and this is to run the Java code. Note it down. Now let's proceed further to the Java code. As you can see, it's a .java extension. Now in the code, as you can see also, we have imported some of the libraries for the functioning, and we have created a public class named LSM9DS0. Now bus.getDevice will have the address of the sensor, that is 0x6A, which is for the gyrometer. Now moving forward, we in the writing section we have selected control register 1 having address 0x20, and the command here we have sent is to X, Y and Z axis enabled, power on mode, data output rate equal to 95 Hz, and that goes for 0x0F. Then we have selected control register 4 having address 0x23, and we have the command for full scale 2000 DPS and continuous update mode, which goes for 0x30. After that, we are reading 6 bytes of the data, as you can see, from the address 0x28 till 0x2D, and it's a 6 bytes for gyroscopic data for 3 perpendicular axes X, Y and Z. Then we have the conversion of the data takes place for the gyrometric values, the data which is converted according to the guidelines provided in the datasheet for LSM9DS0. Then we have bus.getDevice, and there is another address, that is 0x1E, which goes for accelerometer and magnetometer for the sensor. Now in the writing section we have selected control register 1, and it's 0x20, and the command here we have sent is to enable X, Y and Z axis, power on mode and accelerometer data rate output equal to 100 Hz, and it goes for 0x67. Then we have selected the control list 2 and it's 0x21, and the command here is for full scale detection or selection for accelerometer. It's plus minus 16G, as you can see 0x20 for that. Then we have to select control list of 5 and 0x24 for that, and command here is for magnetic high resolution output data rate equal to 50 Hz, and it goes for 0x70. After that we are selecting control register 6 and it's 0x25, and the command here is to select the magnetic full scale range and plus minus 12 gauss, and it goes for 0x60. The last command in the writing section is to select the control register 7 which is 0x26, and we are sending a command for normal mode magnetic continuous conversion mode, that is 0x00. Then we have a delay of 300 millisecond, and after that we are reading 6 bytes of acceleration data from the address 0x28 for the 3 perpendicular axes X, Y and Z. The conversion of the data takes place for the acceleration data. After that we are again reading 6 bytes for the magnetic data from the address 0x08 for the 3 perpendicular axes, and here comes the conversion part of the magnetic data. After the conversion of so many data, what we require is to print the output on the screen, and which goes for the X, Y and Z axis of rotation, acceleration in X, Y and Z axis, and at last we have the magnetic field for X, Y and Z, which are the perpendicular axis. As you can see, we have a very generalized code for this particular sensor, and all the 3 values for gyrometer, accelerometer and magnetometer. Now what do we require is to have a look over the practicality, the working part of this code along with the sensor. Let's have it. Well, coming to the working part, the first step is to copy this entire code of the Java, as you can see, and open up the terminal for the Raspberry Pi via internet, and here create a new file for the reference.java, as you can see, and here we go, paste the entire code here and then save it. And then this command is for the compilation of the code, as you can see on my screen, and here we go, the code is compiled. Now this is the command to run the code, and let's see what we got. As you can see, we have the X, Y and Z axis of rotation along with the acceleration and magnetic field in 3 perpendicular axes. Now when I again run the command, you can see the results there, and the results are almost stable, constant, because there is no motion or no change in the magnetic field. But when I rotate the sensor, and you can see the changes for the acceleration and the rotation in the X, Y and Z axis, along some changes in the magnetic field. Yeah, there you go. And also when I bring a magnet near the sensor, you can see the changes specifically in magnetic field in 3 perpendicular axes X, Y and Z, just like that. Yeah. Now this is how the sensor responds to the Java code. Now what do we require is to have a look over the benefits and the application regarding the sensor LSM9DS0. Let's have it. The LSM9DS0 is a system in package featuring a 3D digital linear acceleration sensor, a 3D digital angular rate sensor and a 3D digital magnetic sensor. The LSM9DS0 has a linear acceleration full scale of plus minus 16G till plus minus 16G, a magnetic full scale range till plus minus 12 gauss, and an angular rate of plus minus 2000 degrees per second. The LSM9DS0 include an I2C serial bus interface supporting standard and fast mode, and an SPI, a serial standard interface. Due to these features, the sensor LSM9DS0 is useful in applications like indoor navigation, smart user interfaces, gaming and virtual reality input devices, and display map orientation. As you can see, this sensor is available on the website controleverything.com, and you can purchase the sensor from here. You can also have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would make it clear that for any further queries, you can reach us on controleverything.com and you can post your comments on the community page. For articles and blogs which are relevant to this video and the sensor, you can go to instructables.com, and to subscribe more video tutorials like this, you can have a look over and subscribe our YouTube channel. I hope you enjoyed this video and had a good one yourself. Thanks a lot.